Welcome to Lesson 2 from Chapter 6 on more about triangles. This lesson focuses on altitudes and perpendicular bisectors. By the end of this lesson, we will be able to recognize altitudes and perpendicular bisectors. Let's start with altitudes. An altitude is a segment of a triangle drawn from a vertex perpendicular to the opposite side. So in taking a closer look at this definition, it's going to be a segment drawn from a vertex. So we're starting from a vertex, but we're talking about perpendicular here, which remember that means that it's going to create a 90-degree angle. So if I just start with the straight and forward, I'm going to start with this vertex up top. Instead of making a segment so that it cuts this side in half, I needed to create a 90-degree angle relationship with that opposite side. So these sides down here are not congruent like the median creates. This is a segment that is perpendicular to this opposite side. That's the key with the altitudes. So when we have a triangle on a coordinate plane and we're supposed to draw altitudes, we need to remember the relationship between perpendicular slopes. Perpendicular slopes are opposite reciprocals. So the first thing I'm going to do is I'm going to find the slope of GH. And the slope of GH we're just going to count, which is 3. So the slope of the line perpendicular to GH will have a slope of -1/3. So starting at the vertex that is opposite of that would be S. So I'm going to use the slope of -1. So I'm going to go up 1 and to the left 3. Up 1 and to the left 3. And I'm going to continue in this pattern to create a line. And because I used the opposite reciprocal, I know that that is perpendicular. So looking at side GS now, that's a slope of -1. So the slope of a perpendicular line to GS is going to be +1. And I'm going to start here at H because that is the vertex that is opposite of GS, and I'm going to use that to create my perpendicular segment. And again, because I used opposite reciprocal slopes, I know that that's going to be perpendicular. My last vertex starting with G, I don't need to do any calculations because HS is a horizontal line, so I just need to create the straight vertical line from G. So there are my 3 altitudes. One thing to really think about with the altitudes is that the altitudes are just another word for height. It does tell you the actual height of the triangle and how far the triangle is from the base. So what we have here is we really have 3 options. When we have an acute triangle, which is what we have here first, when we have an acute triangle, the altitude, which is this dashed line right here, will be in the triangle. Okay, so when you have an acute triangle, the altitude will always be in the triangle. When you have a right triangle, the altitude will always be on the triangle. So notice that you don't have any dashed lines here because this is the actual altitude right here. There's that perpendicular base. This is the actual altitude. That's the height of the triangle as compared to the acute where it was on the inside of the triangle. And then last but certainly not least is the obtuse triangle. And the obtuse triangle, that altitude is outside of the triangle. So that dashed line is out of the triangle. So you have in, on, and out. And again, it has to be on the outside of the triangle if it's obtuse because it's telling us how far off the ground that height of the triangle actually is, the altitude. And so altitude and height, even outside of the math world, are interchangeable words. Okay? They mean the same thing, how high something is. So with this one, I want you to go ahead and see if you can identify the altitudes from this set of triangles. If it is an altitude, I want you to circle it. If it is not an altitude, I want you to cross it out. Go ahead and do that on your own, and then hopefully you can check your answers. Answers are up. One thing that you really want to be checking for is a perpendicular line from a vertex. So you can start with the perpendicular. Like I almost went ahead and just circled all the ones with the perpendicular right angle there. However, this triangle down here is perpendicular, but it is not coming from a vertex. So this is not an altitude. These 4 are altitudes. These 3 are not. So example 4 here has a right triangle big right triangle here, KHT. Then it has another right triangle, HET, which also then creates HEK. There is another right triangle, KHC, also, and then if you look in here, because this is a right triangle, you also have the triangle KEP. So when it comes to naming an altitude, there are a lot for you to choose from. So we're actually going to skip right down to question B. Is there more than one? And the answer is yes. Now, because they are right triangles, the altitudes will be on the triangle. Okay, so when we are dealing with this KHT triangle here, this big right triangle, the altitude of that triangle would be KH. Okay, I'm just going to do a couple more here. If I use the triangle HET, then the altitude of that triangle would be HE. And if I did the KHC triangle here, actually, I'm not even going to identify that one, but it's the same KH altitude. And there are several others in there, but that's just to show you some of your options. And now the next question talks about a median, which we'll have to remember from yesterday's lesson. A median, remember, is from the vertex to the midpoint. So I'm just going to write that here just as a quick reminder. So the fact that it is a midpoint means that we should be looking for congruent markings. So if we look back here on our triangle, after cleaning up all of the altitude markings, these are our congruent tick marks right here. So C is a midpoint, so a median would have to be this KC segment here. So KC is the only midpoint on that particular diagram because it is the only one creating congruent segments. So there is not more than one. Moving on to the second part of the lesson, we're going to talk about perpendicular bisectors. So a perpendicular bisector is a line or segment that bisects one side of a triangle. One thing to notice about the perpendicular bisector is that this is the first segment that does not start with a vertex. The median from lesson 6.1 starts at the vertex and goes to the midpoint. So if I were to actually use this diagram here, because I know that this is creating two congruent segments here, this green line would be the median because it's going from the vertex to the midpoint. Okay, the altitude would be from the vertex going straight down, because this is a horizontal line, going straight down to create a right angle over here. So the purple line would be the altitude, the green line would be the median, and oops, let me spell that correctly. But the original diagram here with the black, that is the perpendicular bisector. So it's not coming from the vertex. We have to start first with the side, find the midpoint, and then create the 90-degree angle from there. So it has nothing to do with any relationship over here. It's strictly a relationship with one side, find the midpoint, and create a perpendicular line. So now let's look at the relationship between those things on an isosceles triangle. When you have specifically an isosceles triangle, which remember is when two of the sides are congruent, so these are the legs and this is the base. Whenever you have an isosceles triangle, the altitude is the perpendicular bisector. And not just that, it's also the median. All three of these things are the same segment because it starts from the vertex and it goes to the midpoint, which is the median. It starts from the vertex and it creates a perpendicular line. And if you start down here at the midpoint and go up, that's the perpendicular bisector. So it does all three, that same segment. Notice that all I did was retrace the same segment here. That same segment is all three of these things, specifically in an isosceles triangle. When it comes to creating perpendicular bisectors, we're going to start with a triangle on a coordinate grid, and we're going to start with simple triangles where it will be easy to count where the midpoint is, but that's exactly where we have to start. So I'm going to go ahead and I'm going to start at the midpoint of this easy horizontal line CE, because all I have to do is count how long it is and figure out the midpoint. So if I count how long it is 10 segments or 10 spaces long. So if I go out to 5, this right here is 1, 2, 3, 4, 5 blocks in. So that point is going to be the midpoint. So I'm creating congruent segments there. And since it is a horizontal line, in order for me to get the perpendicular, all I have to do is draw a vertical line. So that is the perpendicular bisector of for side CE. With the slanted sides, I'm going to look over here at AE. We've drawn them in a way, it's created in a way that this is going to be actually pretty simple. So I'm just going to count 1, 2, 3, 4, and over 1 is a nice point. 1, 2, 3, 4, and over 1 is another nice point. So this point right here is going to be the middle of AE. So I've got 2 congruent segments over here. And then I need to find the perpendicular slope. I'm not just using the grid lines here, okay? We can't just do that because AE is not vertical. We can't just use the horizontal grid line. We have to find the slope of AE, which I did already count as -4. So perpendicular to that would be a positive 1/4. So I'm gonna start at this midpoint that we found, and I have a positive slope. So I'm gonna go down 1 and then to the left, 1, 2, 3, 4. And then I will use that to create my line. And there's my perpendicular bisector. The final side, AC here, has a slope of 1, going up 1 nicely. So I'm just going to count how many diagonals it is. 1, 2, 3, 4, 5, 6, 7, 8. So in order for me to find the midpoint, I'm just going to count up 4. 1, 2, 3, 4. And I'm going to go right here. And since this original slope is a positive 1, my perpendicular slope should be a -1. So I just need to go down there. And that's going to be my perpendicular bisector off of that side. And notice that they're all meeting at one specific point. And of course, that one specific point does have a fun little name. It is called a circumcenter. But that is just an extra little note, and it's not something specifically you guys need to know for this particular lesson. This concludes lesson 2 on altitudes and perpendicular bisectors. So how do we recognize altitudes and perpendicular bisectors? Altitudes need the box, which represents the right angle and connect with a vertex, while the perpendicular bisectors need the tick marks and the perpendicular 90-degree relationship. Before I let you loose here, I want to take a quick summary of medians, altitudes, and perpendicular bisectors. So remember that a median starts at a vertex and goes to the opposite side, creating 2 congruent segments. That's the median. Using that same vertex, an altitude for an obtuse triangle like I have here is on the outside of the triangle, and that creates a 90-degree angle with the side opposite. But in this case, because it is an obtuse, it would be on the outside of the triangle itself. Finally, the perpendicular bisector starts at this midpoint, so not that vertex A, but starts at this midpoint B that we already created with the median, and that goes straight to create a 90-degree angle with that side. So this is a quick summary of median, altitude, and perpendicular bisectors all on one triangle.